Hi students, welcome to the next topic from electrostatics, and we are going to find out the equivalent capacitance. Last class we have studied about the non-Weiston's bridge combinations. Today's lecture we are going to see how we can find equivalent capacitance of a cube. This is simply a cube, so each of the area or each of these corner areas, this area, this area, this area, this area, everywhere we are going to connect with a capacitor. Now for this cuboid structure, how we can find the equivalent capacitance? The same question you may going to face in current electricity also. There also, instead of asking capacitance will be here, they will ask you about resistance. So we will first complete the diagram. This is simply a cube. Now we are going to connect with a capacitor each of the edges, and we'll see what is the total capacitance. Okay, so we are going to connect the capacitor at various terminals or various edges. So here I am connecting, here I want to connect, I want to connect here also, I want to connect here, I want to connect here, here. So I'll just clearing that those areas where I want to connect capacitance. So here capacitor, here we have capacitors. Hope every surface I have covered. Let me first complete this one. So I have one capacitor here. I have another capacitor here. I have another capacitor here. I have another capacitor here. This edge and this edge and this edge and this edge. Here also we need one. So all the edges is filled with a capacitor. So all the edges, it's filled with a capacitor. Now the question is asking what is the equivalent capacitance between A and B. Between A and B, the equivalent capacitance. How we have solved the same topic for a non-Weiston's bridge. The same way here also we are going to solve it. So first what we'll assume, we will connect with a voltage source between A and B. So I am assuming I connected with a voltage sources of A and B, between A and B. This dotted line is the extra things in which I have connected. I am supplying the voltages. So I am assuming here you can see three capacitors, one root, right side, left side and bottom. So three way it can split. So I am assuming, you can assume any value. I am assuming 6Q charges are coming. Why I am assuming like a 6Q? You can assume like a 3Q also. So 2Q will go in this direction and 2Q will go in this direction and 2Q will go in this direction, because I want an equal splitting. Okay, to make my mathematical calculations easier, I assume 6Q. Suppose if you are a guy and if you are assume it as 3Q, then what will happen? Q will come. All the cases answers will be same. Suppose if you are assuming Q will be here, then Q by 3 will be here. So in order to avoid the mathematical complexity which is related with this one, I assume 6Q is a charge which is coming. You can assume any charges. So of course you know this is a positive place, this is a negative place, positive place, negative place, positive place, negative place, because it is connected with positive. So now we'll see. Now we need any one path we have to choose. Suppose if I am choosing this path, okay, so I need to choose one path. For example, from positive to negative, I need a closed path. So this is a path I am choosing. I am going like this and coming like this and going like this. This is a path in which I am choosing. You can choose like this also. Any way you can choose it. Suppose we are starting from here, going here, then you are coming here, then going down, then going to B. This is one way of choosing it. Suppose if you are choosing, okay, I am going down like this, going towards right, then I am coming here. You can choose it any path. This is a very simple one I have chosen. Okay, now 2Q will be coming, will be here. What will happen? The 2Q will split, right? Here Q will split, here Q will split. So this is positive, negative and positive, negative. Next, we know 6Qs are coming. So totally all the 6Q will join and 6Q will go outside. So directions are opposite, coming and going. So minus 6Q will be here. If it is minus 6Q means from here what is coming? Minus 2Q will come. From here minus 2Q will come. From here minus 2Q will come. All together will join. Minus 6Q is going out. So 6Q is coming inside and 6Q is going outside. Now we'll see. See here Q is coming. So definitely from here what is coming? Q. These Q and Q together will join, will get minus 2Q. Okay. So why this is, why I'm representing it is minus Q? You can just represent it as 2Q itself. Okay, 2q will be here. Now if you have look into this sign, this is connected with the negative terminal, so this is negative and positive. So this area is negative, so negative and positive. This area is negative, negative and positive. So similarly you can also fill these areas also. I am not filling this area because I don't want to make the diagram which become more unreadable format, because if this 2q will be here, it is splitted q and q. But my interest is on the right wing. On the right wing, this is enough for me. So I got 2q will be here and q will be here, and 2q will be there on the right side. So what I am going to do, I am applying the Kirchhoff voltage law. So total voltage is equal to 0. Summation of the voltage equal to 0. That is called KVL, Kirchhoff voltage law, right? Total voltage in a loop equal to 0. So what is voltage? So we know Q is equal to CV. So voltage equal to Q by C. This is a general equation. Now we'll apply for each of this one. Here 2Q, we are going from plus to minus. So it is, we are decreasing plus to minus. So minus 2Q by C. Each of the capacitance value is assumed to be C. You can mark C, C, C. Everywhere it is C. If there are any specific values will be given in the question, then we have to use that value, else C. So minus 2q by C, this voltage is over. Next voltage is where? So we are coming here. Here it is plus q2. So again minus q by C. Then we are going will be here. Again plus to minus. So minus 2q by C. Okay, all this minus q will join and going exit. So plus 6q is coming and going. This is coming inside. That's what it is plus. This is going outside. That's what it is minus 6q. So this is a voltage here, first voltage, and second voltage is this one, and third voltage is 2q by C. Again from, I am moving from plus to minus, negative, I am moving from plus to minus, negative, I am moving from plus to minus, it is negative. Negative means decreasing. This is a total voltage. Okay, total voltage over a closed loop will be equal to 0. So what else will be here? Here I can say total voltage in a loop will be equal to 0. Now in a loop, this voltage also I have to add, because I started from here and I am going here and going here. Then I have to move back like this. This is my closed path, starting from positive, going to negative, and I have to reach the final position. Here if you see, I am going from where to where? This is my route. I am going from minus to plus. So what is the charge? Plus 6q. Plus, you have to look into this polarity, 6q divided by C equivalent. Okay, why the minus 6q is coming? Because of the direction. To represent the direction only minus 6q is written. You don't want to write minus 6q, you can simply write 6q also. That is also correct, because here it is coming, that's what I taken plus, here it is going, so you can take it as minus. Why I am representing minus? In order to represent the direction. So you don't want to bother about the directions will be here. This is 6q and you are going from minus to plus, so you are increasing, so it is positive. Total voltage is equal to 0. Okay, what will get cancelled will be, all q will be getting cancelled will be here. So I can say minus 2 by C minus 1 by C minus 2 by Z is equal to minus 6 by CE. This I am taking to right hand side. So I have to simplify, right? Throughout I am multiplying with 6. So let me see what I will get. Oh, okay. Throughout I am multiplying with the minus first. So it becomes 2 by C plus 1 by C plus 2 by C is equal to 6 by C equivalent. Okay. So 2 by C plus 2 by C plus 2 by Z means what? 5 by Z equal to 6 by C equivalent. From this one I will get C equivalent is equal to what? 6C by 5. 6C by 5. This is the equivalent capacitance of the cuboid. So this is a value which is representing the equivalent capacitance, 6C by 5. So 6C by 5 is equivalent capacitance. If the same question is asking, if it is replaced with the capacitor is replaced with the resistor, then for the same cases I am writing an additional information. In that cases, equivalent resistance equal to volta. Capacitor and resistance are opposite. So you can write it as 5 by 6R. This is for equivalent resistor and this is for equivalent capacitance. Hope you understood how we are finding the total capacitance of a cubical structure. You can assume the value as I told before, 6q I am assuming. If you are assuming like a q, then q will be here. Then again it is a difficult because it fraction will be here, q by 2 will come. In order to avoid all such complication, I assumed 6q because I know 6q will be split into 3, 2q, then 2q will be split into q and q. So my mathematical calculations are quite easy. To make it easy, I used the 6q. Always remember, in order to apply Kirchhoff voltage rule, you are starting from one point and you need to find a path to negative. From there you have to complete the path. Along this path you are applying Kirchhoff voltage law. Where and all voltages are available? Here voltage available, here voltage available, here voltage available, then coming, then here voltage available. So totally 1, 2, 3, 4. You can see 4 terms, 1, 2, 3, 4 terms. Total voltage is equal to 0. This is nothing but in your current electricity you are call it as KVL, Kirchhoff voltage law. So here voltage equal to Q by C. So you will be here, 2Q is a charge. So 2Q by C. From where to you are moving? You are starting from here. This is your root. So you are going from plus to minus. So plus to minus means decreasing. So you put negative. Then second term is what? Q by C. Again you look the sign, plus to minus, decreasing, negative. Then finally you are coming will be here. Here you are going from minus to plus. Battery, positive is connected here, negative is connected here. You are going from minus to plus. So it is increasing. Increasing means you have to put 6Q divided by CE is equal to 0. You don't want to bother about the sign of the Q charge. Q is a total charge which is coming from one end, splitted into different branches of the cuboid, and finally everything will be joining and forming into the section of B, into the terminal of B. So this is the equivalent capacitance of the cuboid structure. Hope you understood this topic. Students, you can see in the board so many things will be there, right? Okay, so don't worry, this is a simple stuff. Last topic we have learned about cube, and the previous sessions we have learned about how to solve a non-Weiston's bridge. Non-Weiston's bridge based circuits. Okay, this is actually a shortcut. Okay, definitely those who are going for engineering studies, they will definitely learn this in their engineering first year or second year, third semester I guess. But if you are in going for medicine, you will never learn this on your undergraduation degree. But don't get surprised what you have seen will be here. Okay, this is a kind of what I can say, this is a kind of logic, and this is already have a set of derivation and other stuff will be there, but that is not at all required. Anyway, this is, you can see like a star to delta and delta to star conversions actually. So you are not going to, this is not there as such in your syllabus, but this will be very helpful to solve some tricky and some challenging question where most of the students will make an incorrect answer, where we can make correct answer. That is the beauty of this one. So we'll say star to delta and delta to star conversion. What is this means to us? You can see star means it's a Y structure, right? Y to delta. So I can convert a circuit, if it is in Y structure, I can convert into delta structure. Or another way, if a circuit in delta structure, I can convert into Y structure. So two Y's will be there. This set of formula you have to by heart. Okay, definitely it should be there in your mind so that we can easy to answer it. But we will be little bit careful, and you don't want to like this is quite easy. Okay, so I have written here a resistance network and here a capacitance network. So you can learn about a resistor network so that the capacitor network will be helpful. The same concept, whatever you are going to learn it here, the delta to star and star to delta conversion method, you can use it on your current electricity chapter also. That is the I can say the trickiness of this topic. We will see this one, what it is there. You can see the blue color R1, R2, R3. This R1, R2, R3, the blue color alone will form a Y structure. I need to convert this Y structure into a delta. Delta is a triangle structure, right? So this R1, R2, R3 can be converted into RA, RB, RC. This is these 3 together, it's form a delta network. Now, what is the formula for RA? The formula for RA is equal to, you see how many RA is equal to the product of all the two resistance, which means R1, R2, R2, R3, R1, R3. This comes in the numerator, and what is comes in the denominator means if your RA will be located between R1 and R2, then you have to divide with the opposite resistance. What is the opposite resistance to RA? RA is adjacent to R1 and R2. Your opposite resistance is R3. So you are dividing with R3. Now, if you see, will be here RB. So RB means again the numerator. It's a product of two resistance R1, R2, R2, R3, R1, R3. So all these three terms, numerators are same. See, numerator same, numerator same, numerator same. But only the difference is the denominator. If you see RA, then opposite to this R1, R2, which means R3 will come in the denominator. If you look into RB, then R1, R3 are adjacent. Opposite one is R2 will come in the denominator. If you look into RC, then what will happen? R2, R3 are adjacent to RC. Opposite one R1 will come in the denominator. So you are converting a star network. R1, R2, R3 is given to you. Then you can say like RA, RB, RC you can draw. This is I drawn with a different color, black color. From that you can convert the delta network, and how you can convert a star to a delta network. So if somebody is drawing R1, R2, R3, you can say the same network, you will get the same equal resistance if you are drawing in a delta structure. That is what written here in the first three. Next we will go to this part, delta star network. Delta star network means if RA, RB and RCs are given, the triangle is given, you need to convert into a Y structure. Y structure means R1, R2, R3. Suppose RA, RB, RC is given, from that RA, RB, RC, how you can able to find out R1, R2, R3? That is a question. So see, if you want to find out R1 is connected with these two, right? This is an easy way to remember. That's what I'm saying. R1 is connected with RA and RB. So RA and RB product will come in the numerator. RA, RB whole divided by sum of the resistance. RA plus RB plus RC. If you look into R2 is connected with the RA and RC. So that will come in the numerator. RA, RC divided by sum of the resistance. RA plus RB plus RC. Now, if you look into R3 is connected with the B and C. So in the numerator RB, RC product divided by sum of the resistance. This is a conversion of delta to star network, and here it is star to delta network for a resistance circuit. Now the question is like, if the same question, this is applicable for definitely 100% for your current electricity circuit. Wherever current electricity circuits are coming, you can solve this one. Where all these things we are going to apply, we will see on the subsequent topic. Now we'll come to capacitor. If you are very thorough with the resistor network, or if you are thorough with the capacitor network, only one you have to learn. Either this star to delta and delta to star for resistor network. Then capacitor will be simple. If you look into will be here, you can here itself will be C. See, RA is replaced with the CA. Here one mistakes. This is not CA. This is 1 by CA. 1 by CA. 1 by CB. 1 by here. 1 by C1. 1 by C2. 1 by C1. Okay. So 1 by CA. RA, everything is reciprocal. RA become 1 by CA. Next one, what is available will be here R1, R2, 1 by C1, 1 by C2 plus R2, R3, 1 by C2, 1 by C3, R1, R3, 1 by C1, 1 by C3 divided by R3. R3 means 1 by C3 will come. Same case for 1 by CB, 1 by CC. 1 by C1, 1 by C2, 1 by C3 for delta to star network. So, in electrical potential and capacitance, of course, we are dealing more with the capacitance. In current electricity, you are dealing more with the resistance. But here we are dealing with more with capacitance. So this part is important for us. So why I am teaching to you the above part is, this is useful for your current electricity, as well as if you learn this formula, we can apply this formula will be here in a reverse order. Okay, so always I remember personally my case, I remember this formula. Then once I will write this formula for star to delta or delta to star, what I will do immediately means, if it is a capacitive network, I can write it. So suppose if I want to find out RA, okay, suppose if I want to find out CA, I will assume this is like a resistor network, then I will write the formula for RA. Then I know the real question is not resistor, real question is capacitance, then I will write the capacitance formula like this. This is what, while getting some questions, while seeing some problems, this is what I personally doing that, because that is giving more convenience to me. How you are comfortable, you can learn that way. I guess you are also will travel along with my mindset only. You can learn about the resistor network if so, and everything you can reverse it for a capacitor network. So capacitor actually you don't want to learn. Resistor if you learn, you can just reverse it. Questions may come either with resistor or with capacitor. Now you have a questions like, we learnt star to delta, delta to star. This 1, 2, 3, 1, 2, 3. So totally 3 plus 3, total 6 formulas will be there for resistor. This definitely you have to remember. Okay, mandatory, it's very important. And capacitance, the another 3 and another 3, total 6 will be there for capacitor. So if you learn 6 resistor formula, then 6 capacitor formula is a bonus for you. Okay, so this is what is the concept. Now of course you have a questions like where we are going to use this one. Of course, the star to delta and the delta to star method, we will use it to solve some complex problems. As an example, non-Wheatstone's bridge circuits. So we already solved a non-Wheatstone's bridge circuit. We will see the problem of a non-Wheatstone's bridge circuit, and we will do based on this method, and we will see whether we are getting the answer for the question. This is what is the agenda, this is what is the intention for learning this one. Hope you understood what delta to star and star to delta conversion. This is quite important, not a part of your syllabus as I told before, but it's really important to answer certain questions in a very fast way. This is like a kind of shortcut method. We'll see how we can solve the non-Wheatstone's bridge circuit using a shortcut. Shortcuts we already learned, right? The shortcut is nothing but star delta or delta to star conversions. We already done one problem with respect to Kirchhoff voltage rule. Hope you remember, right? Just before doing the cubical structure of capacitance, we already concluded one questions with respect to a non-Wheatstone's bridge circuits. I'll just recollect that information will be here. We already solved a non-Wheatstone's bridge circuit like this. Capacitor here also, next capacitor, next capacitor, next. So this is like 2 microfarad, 1 microfarad, 2 microfarad, 1 microfarad and 2 microfarad, the terminals A and B. The question is, that time I asked it, what is the equivalent capacitance between the terminals A and B? If I look into the ratio 2 by 1, 2 by 1, it is 2. 1 by 2, so which means 2 by 1 is not equal to 1 by 2, so it is non-Wheatstone's bridge circuit. So for that we applied the Kirchhoff voltage law, and finally we got the equivalent capacitance of this system is 10 by 7 microfarad. Of course 10 by 7, 10 by 7 equal to 1.428, okay, microfarad. Okay, so this is a value we previously got for this question as an answer. So hope you remember that value. If not, just go back a little bit of a couple of pages back on your notebook so that you can see we got this value. Next, we are going to solve the same questions in a much more simple way, but I cannot say like it is not very much time saving work, but yeah, the method will be easy. The shortcut method is nothing but star to delta and the delta to star conversions. We'll see what we can go into use will be here. So remember this value, this is what we got previously. Next, here We are going to solve the same questions with the help of that. So 1 microfarad. Now look, it will be here. You can see one T-shaped structure will be here, right? One T-shaped structure. This is a T-shaped structure. This is a T-shaped structure. 2 microfarad, 1 microfarad, and these 2 microfarad. This all together, this is a T-shaped or a star network. So there is a star network will be here like this. And here 2 microfarad, 1 microfarad. We are going to convert this star into delta. Star into delta. So remember this 1 microfarad I will keep it here, and 2 microfarad I will keep it here. So what I am going to do means, with the black color I am going to show you, I am going to create one delta network here. This is one capacitor, and this is next capacitor, and this is the next capacitor. I am going to create this one. This capacitor is given as CA, capacitor is given as CB, capacitor is given as CC. We are going to find out this value. So definitely just before we have written what is the star to delta converted for a capacitance. So I know 1 by CA is equal to, okay, 1 by C1, 1 by C1 into 1 by C2 plus. You can assume like this is C1, this is C2, and this is C3. So what is the formula? 1 by C1, 1 by C2 plus 1 by C2, 1 by C3 plus 1 by C1, 1 by C1, C3 whole divided by the opposite branch. Opposite branch means 1 by C3. Okay. So for all the formula, if you have writing for 1 by CB, so 1 by CB, the numerator is same, right? 1 by C1, 1 by C2 plus 1 by C2, 1 by C3 plus 1 by C1, 1 by C3 whole divided by CB means this side. So for this side, these two are adjacent, the other one is opposite. So we have to divide with the opposite one, 1 by C2. For CA, C1 and C2 are adjacent, opposite is C3. That's what we are divided with C3. We are going to the next one. 1 by CC is equal to, again numerator is same, 1 by C1, 1 by C2 plus 1 by C2, 1 by C3 plus 1 by C1, 1 by C3 whole divided by CC. So these two, C2 and C3 are adjacent, opposite is 1 by C1. Now we have to substitute the value and we'll calculate it. So this is equal to, this equal to, this equal to 1 by C1 into 1 by C2. 1 by C1 means 1 by 2 into 1 by C2 means 1 by 1, which is nothing but 1 by 1 plus 1 by C2, 1 by C3. 1 by 1 into 1 by 2 plus 1 by C1, 1 by C3. So 1 by 2 into 1 by 2 whole divided by 1 by C3. 1 by C3 means 1 by 2. So what is this will come? 1 by 2 into 1 means 1 by 2. 1 by 2 into 1 means 1 by 2. So this 1 by 2 plus 1 by 2, half means full, which means 1. So 1 plus 1 by 4. 1 plus 1 by 4. How much will come? 1 plus 1 by 4. So this become 1 plus 1 by 4 divided by 1 by 2. 1 plus 1 by 4 means 5 by 4 divided by 1 by 2 means how much you will get? You will get 5 by 2. Okay. So numerator for this also will be the same, 1 plus 1 by 4, which means 5 by 4 whole divided by, what is 1 by C2? 1 by C2 means 1 by 1. So 1 by 1, which is equal to 5 by 4. Here also numerator is same. Numerator we got 1 plus 1 by 4, which means 5 by 4 whole divided by, denominator is 1 by C1. 1 by C1 means 1 by 2. So this become 5 by 2. Now this is a very common mistake every student has to do. Now you are getting 1 by CA. You are not getting CA. So to get CA, you need to revert these values. So that's what we are going to do. CA is equal to, you got 1 by CA 5 by 2. So CA is equal to 2 by 5. And CB is equal to 4 by 5. And CC is equal to 2 by 5. So CA is equal to 2 by 5. CB is equal to 4 by 5 and CC is equal to 2 by 5. So we got all the values for this one and we have to make use of this value. Now this is clear. A star network I converted into delta network, I got couple of values. Now I'm going to redraw the circuits and we'll see what is happening. Okay, so I'm clearing this area because I need some space to do the rest of the things. Fine, perfect. Got it. Okay. So now I am redrawing the circuit with the CA and the CB and CC. So now the first network is I have a CA capacitance which is equal to 2 by 5. So there is no C1, there is no C2, there is no C3, and we have another capacitor and that is called CB. So CB is equal to 4 by 5 and we have another capacitor that is called CC. So CZ is equal to 2 by 5. Next, what is extra? The circle ones are extra. The circle one is connected from here to here, which means two ends of the CB 1 microfarad is connected. So this is one end, another end is here. Okay, so we are going to find out equivalent capacitance. A will be here and B will be here. What is this value? 1. And we are going to connect the 2 microfarad and one end is at CC, one end, another end at CC. So we have two ends will be like this. Okay, so it is 2 microfarad. So 2. Now this is a structure. Now easy, you can say these two are what connection? Parallel connection. These two are parallel connection. Okay, so we are going to find out the equal resistance of this parallel combination. So these two are parallel combinations. How to find the parallel combination? C1 plus C2. So we are adding this one. 1 plus 4 by 5, which is equal to 9 by 5 this side. This side also I am adding. So how much I got it? 2 by 5 plus 2, which is equal to 12 by 5. Now from this one I am drawing the equivalent circuit will be here. So the top capacitance nothing but 2 by 5 and I have another capacitor, these two. This is A and this is B. What is the bottom one? Bottom one, this all together 9 by 5. And here it is the next one. So this is 1 and this is 1. So the next one is 12 divided by 5. This is my short. Now again as I told, I need some space will be here. So to clear the space, now this is my final circuit. You can pause the video and you can complete your notebook. Okay, so I don't want to wait it, right? So that is the advantages of this online classes, because yeah, we can move. You can pause it and you can write it. So 2 by 5 and 9 by 5 and 12 by 5. Now these two are what connection? These two are series connection. How to find the series? C1 C2 divided by C1 plus C2, 2 connections. So 9 by 5 into 12 divided by 5 plus 9 by 5 plus 12 divided by 5 is equal to 9 into 12, 108 whole divided by 25. 25 will come to denominator. 5 and 5 will get cancelled. 5 into 9 is 45 plus 5 into 12 means 60. So 108 divided by 105. That's all. So now again back I am redrawing the circuits. I got 2 by 5. I got the another value 108 divided by 105. This is a terminal A and this is a terminal B. Now we are calculating the equivalent resistance of this one. Equivalent capacitance. So C equivalent, 2 are in parallel connections, we can add that. So 2 by 5 plus 108 divided by 105. 105 is taken as the LCM. 105 in 5, 21 times. Okay, so 21 into 2, 42 plus 108. 150 divided by 105. We can cancel with 5. So 150 means 30. 30 into 5 is 150. Whole divided by 105, 21. 31 divided by 21. This is what we got answer. Previously what we got? 10 by 7. Okay, so I can say 30 divided by 21 equal to 1.428. This is nothing but this is same as 10 by 7. Both are same. Values are look like values are different, but final value will be same. 30 by 21 is equal to 10 by 7. This is same, right? Both are same, because if you multiplied here with 3, here with 3, both will be same. 10 into 3, 30, and it is 7 by 3. So both values are same. This is also equal to, instead of writing in a factual value, you can write a 10 by 7. So both values are equal. Either you can do with the Kirchhoff voltage law, that is up to you. Okay, that is up to you. And this is an example of a star to delta method we are used to solve a non-Wheaton's bridge circuit. Whichever is comfortable, try to learn that. Okay, my recommendation is to learn both, because depends upon certain questions. You can apply whichever is very easy, because in case of a cube structure, okay, it is very difficult to apply star to delta or delta to star method in case of a cubical structure. There you need the charge splitting, like 6q is coming, you are split into 2q, 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 and you are applying the KVL. So that method will be applicable there, but star to delta method you cannot easily apply, will be there. That is a problem, will be there. So in that case you have to learn about this KVL concept. But while come to the non-Wheaton's bridge circuit, you have two options. Either you can go with the charge divisions method and you can apply KVL. Okay, the same question we have done, right? Q is equal to Q1 plus Q2, and Q1 and Q2 we got different value and we solve it. So you can go with that method also, or you can do the same questions with star to delta conversion also. So whatever you are comfortable, you can answer it. So it's up to it's up to you, in the sense like this kind of non-Wheaton's bridge circuit you can do in any way, but you have to learn both star to delta and delta to star method. So I again want to inform you that star to delta, delta to star method, 90% of the students will fall into confusions, because the similarities in the formula. So either learn the resistance formula completely, then take the volta just opposite for the capacitance, so that you will never forget about this one. So these things you must have to learn, and this is not as a part of your I can say like your Ncert syllabus, but this is a concept in which you are going to study in higher standard, but this will be very helpful to solve this kind of questions within a short interval of time. Okay, so hope you understood this topic.